Welcome. Today, we're diving into the concept of one-to-one mapping in Spring Boot JPA. This is a foundational relationship type in database design, where each record in one table is directly linked to exactly one record in another table. Think of it as a perfect pairing, like a user and their unique profile. Understanding this mapping is crucial for building efficient, well-structured applications. Throughout this video, we'll explore when and why you'd use one-to-one relationships, walk through a practical example, and see how it all comes together in Spring Boot with MySQL. One-to-one mapping means that for every record in your first table, there's exactly one corresponding record in a second table. This is different from one-to-many or many-to-many relationships. For example, if you have a user table and a profile table, each user has one profile, and each profile belongs to one user. This direct correspondence is ideal for splitting large tables, handling optional data, or organizing information that's accessed at different frequencies. It's a clean way to keep your data model both efficient and logical. You should use a one-to-one relationship when each row in one table matches exactly one row in another. This is especially useful if you want to split a large table for design efficiency, or if some data is only relevant to certain records. For instance, a user might have a profile with additional details, but not every user needs those details stored in the main user table. By separating them, you keep your database organized and efficient, making it easier to manage and scale as your application grows. Let's look at a practical example, a user and their profile. In many applications, a user's basic information is stored in one table, while additional profile details, like phone number and address, are kept in a separate table. This separation helps keep the core user data lightweight and allows profile information to be managed independently. It's a common pattern in real-world systems, ensuring that each user is always linked to exactly one profile, and vice versa. Get started, you'll need a MySQL database. For this example, let's create a database called userdb. This is where all your user and profile data will be stored. Using the command create database userdb, you set up a dedicated space for your application's data. With the database ready, you're prepared to connect your Spring Boot project and begin defining your entities and relationships. Next, set up your Spring Boot project with the necessary dependencies. In your pom.xml, add spring.boot-starter-data-jpa for JPA support, mysql-connector-java for MySQL connectivity, and spring.boot-starter-web for building REST APIs. These dependencies provide the foundation for working with databases, handling data persistence, and exposing endpoints for your application. In your application properties file, configure the connection to your MySQL database. Set the data source URL, username, and password. For example, use spring.datasource. URL equals jdbc mysql /localhost 3306 /userdb spring.datasource username equals root and spring.datasource password equals rootpassword. Also set spring.jpa.hibernate.ddl-auto equals update to let Hibernate manage your schema, and spring.jpa.show-sql equals true to see SQL queries in the logs. These settings ensure your application connects smoothly to the database. Now let's define the user entity. In your Java code, annotate the class with an entity and use at id with a generated value for the primary key. Add fields like name, and most importantly, a profile field annotated with at one-to-one and at join column. The at join column annotation specifies the foreign key column, profile-id, that links to the profile entity. This setup makes user the owner of the relationship, ensuring each user is connected to one profile. The at join column annotation is key to one-to-one relationships. By specifying name equals profile-id, you define the foreign key column in the user table. This column stores the primary key from the profile table, creating a direct link between the two entities. Explicitly nomming the column makes your code more readable and ensures the relationship is set up exactly as you intend. The referencedColumnName attribute in at join column specifies which column in the target entity is used as the foreign key reference. In our example, referencedColumnName equals id means the profile-id in the user table points to the id in the profile table. This explicit mapping ensures data integrity and makes the relationship between user and profile clear and reliable. The profile entity is also annotated with at entity and has its own primary key. It includes fields like phone number and address. Importantly, it has a user field annotated with at one-to-one, mapped by profile. This tells JPA that profile is the inverse side of the relationship and user is the owner. The mappedBy attribute points back to the profile field in user, ensuring the relationship is bidirectional but managed from one side. The mappedBy attribute is crucial for bidirectional relationships. It tells JPA which entity owns the association. In our case, mappedBy profile. In profile means that user manages the foreign key and the relationship. Profile simply references user but doesn't control the link. This setup prevents circular references and ensures only one side updates the relationship in the database. JPA, the side without mappedBy, is the owner of the relationship. The owner side contains the foreign key and is responsible for managing the association. In our example, user is the owner because it has the profiled column and uses at join column. Profile with mappedBy is the inverse side and simply points back to user. This clear distinction helps avoid confusion and ensures your data stays consistent. Using mappedBy is important when you define bidirectional relationships. It tells JPA which entity is responsible for updating and maintaining the association. By marking profile as the inverse side, you ensure that only user manages the foreign key and the actual link in the database. This prevents data inconsistencies and makes your code easier to maintain. To interact with your user data, create a user repository interface that extends JPA repository. This gives you access to common CRUD operations, like saving, finding, and deleting users, without writing boilerplate code. With this repository in place, you can easily manage user records in your application. Similarly, create a profile repository interface for managing profile data. By extending JPA repository, you get all the standard methods for handling profiles. This separation of repositories keeps your code organized and makes it easy to work with both users and profiles independently or together. The user service class acts as a bridge between your controllers and repositories. It's annotated with @service and uses @autowired to inject the user repository. Here, you define methods like saveuser and getUserById, which handle business logic and interact with the database. This layer keeps your application modular and maintainable. The user controller exposes REST endpoints for your application. Annotated with @REST controller and @request mapping, it handles HTTP requests for creating and retrieving users. By injecting user service, it delegates business logic and keeps the controller focused on handling web requests. This separation of concerns is a best practice in Spring Boot applications. To create a new user with a profile, use the post users endpoint. The request body includes user details and a nested profile object. When you send this request, the controller passes the data to the service, which saves both the user and their profile in the database. This seamless process ensures the one-to-one relationship is maintained. Here's an example of the JSON request body for creating a user with a profile. Name, John Doe, profile. Phone number, 123,456,789. Address, 123 Mainsent. This structure ensures that both user and profile data are sent together, making it easy for the backend to process and store the information in the correct tables. After successfully creating a user, the API responds with the saved user and profile data, including their generated IDs. For example, id1 name, John Doe, profile. id1 phone number, 123,456,789. Address, 123 Mainsent. This confirms that both entities are linked and stored correctly in the database. To fetch a user by ID, use the get/users/id endpoint. The controller retrieves the user and their profile from the database and returns the data as a JSON object. This makes it easy to access both user and profile information in a single request, thanks to the one-to-one mapping. The response from the GET endpoint includes the user's ID name and their profile details. For example, id1 name, John Doe, profile. id1 phone number, 123,456,789. Address, 123 Mainsent. This structure confirms the direct link between user and profile, making data retrieval straightforward. After creating a user, the data is stored in two tables, user and profile. Each user row has a profiled column that links to the corresponding profile row. This separation keeps your data organized and ensures that each user is always associated with exactly one profile, maintaining the integrity of your one-to-one relationship. Splitting data into user and profile tables offers several advantages. It keeps the main user table lightweight, allows profile data to be managed independently, and improves performance for queries that only need basic user information. This design is especially useful when profile data is accessed less frequently or is optional for some users. In our example, the user entity is the owner of the one-to-one relationship. It contains the @join column annotation, which defines the foreign key and manages the association. This means that any changes to the relationship, like assigning a new profile, are handled through the user entity, ensuring consistency in your data model. The profile entity with mappedBy profile is the inverse side of the relationship. It references the user entity but doesn't control the foreign key. This setup ensures that only one side, the user, manages the association, preventing conflicts and making the relationship easier to maintain. Bidirectional relationships allow navigation from both entities. In our case, you can access a user's profile from the user entity and find the user from the profile entity. This flexibility is useful for queries and data manipulation, but it's important to clearly define the owner and inverse sides to avoid confusion. You can test your API using tools like Postman or any REST client. Send a post request to users with user and profile data to create a new record. Then, use get/users/id to retrieve the user and their profile. This hands-on testing ensures your one-to-one mapping works as expected and helps catch any issues early. When you send a sample input, such as a user with a profile, the API processes the data and stores it in the database. The output confirms that both the user and profile are saved and linked correctly. This round-trip test validates your entity mappings and ensures your application is functioning as intended. One-to-one mapping offers several benefits. It keeps your data model clean, separates concerns, and allows for efficient data access. By splitting related data into distinct tables, you can optimize queries, manage optional information, and maintain a logical structure that's easy to understand and extend. One-to-one relationships are common in scenarios like user profile, employee passport, or car registration. Whenever you have two entities that are tightly coupled but logically separate, one-to-one mapping is a great choice. It's especially useful for handling optional or rarely accessed data without cluttering your main tables. Splitting large tables into smaller, focused ones improves design efficiency. It reduces redundancy, makes your schema easier to maintain, and allows you to optimize performance for different types of queries. This approach is a best practice in database design, especially for scalable applications. One-to-one mapping is perfect for handling optional or conditional data. For example, not every user may have a profile, or some profile fields may be rarely used. By separating this data, you avoid storing unnecessary null values in your main table and keep your database lean and efficient. The main annotations used in one-to-one mapping are at entity, at id, at generated value, at one-to-one, and at join column. Together, they define your entities, set up primary keys, and establish the relationship between tables. Understanding these annotations is essential for building robust JPA applications. Spring Boot makes it easy to integrate JPA into your application. With simple configuration and powerful annotations, you can quickly set up entity relationships, manage data, and expose REST-TFL APIs. This integration streamlines development and lets you focus on business logic rather than boilerplate code. One-to-one mapping helps maintain data integrity by ensuring that each user is always linked to a unique profile. The foreign key constraint prevents orphan records and keeps your data consistent. This reliability is critical for applications that require strict data relationships. You can extend the one-to-one model by adding more fields or entities as your application grows. For example, you might add a settings table linked to the user or additional details in the profile. The flexibility of JPA makes it easy to evolve your data model without major changes. Common issues with one-to-one mapping include null foreign keys, circular references, or missing mappedBy attributes. Always ensure that the owner side manages the relationship and that your annotations are correctly set. Testing with sample data helps catch and resolve these problems early. Follow best practices by clearly defining owner and inverse sides, using explicit column names, and keeping your entities focused. Regularly test your endpoints and review your database schema to ensure everything is working as intended. Good design and testing lead to robust, maintainable applications. A simple diagram can help visualize the one-to-one relationship. Imagine two tables, user and profile, connected by the profile id foreign key. Each user row points to a unique profile row, and vice versa. This visual representation reinforces the concept and makes it easier to understand how data is linked. After running your application, you'll see two tables in MySQL, user and profile. The user table includes a profile id column, while the profile table has its own primary key. This structure ensures that each user is always linked to one profile, and the relationship is enforced at the database level. Entity diagrams are a great way to see how your classes relate to each other. In this example, the user entity has a one-to-one link to profile, and profile points back to user. These diagrams help you and your team quickly understand the structure and relationships in your application. Let's recap what we've learned. 101 Mapping in Spring Boot JPA is a powerful tool for structuring your data. By separating related entities, you keep your database clean, efficient, and easy to manage. Remember to define owner and inverse sides, use the right annotations, and test your endpoints thoroughly. With these practices, you'll build robust applications that scale smoothly. Now that you understand 101 mapping, you can explore more advanced JPA relationships, like one-to-many and many-to-many. Continue practicing with real-world examples, and try extending your models with additional entities and relationships. The skills you've learned here will serve as a strong foundation for building complex, data-driven applications in Spring Boot.